Good. Cool. Okay, so welcome to Advanced Expressions for Microsoft Flows. This is a 400 level session. So hopefully, does everybody in the room know what flow is already? Yes? Okay. If you don't know what flow is, put on your headphones, go to YouTube, watch some videos for the next hour, and then you'll know what flow is. But don't watch me talk, because I'm going to be talking about kind of the advanced patterns for Microsoft Flow, not introduction material. So specifically what I'm going to be doing is I'm going to start off with just some top best practices for building out flows before I start talking about expressions, because I think this is something that hopefully you'll find pretty valuable. Just understanding some of the top things that you should be doing with flows, things you shouldn't be doing. And then after I've gone through that, then I'll dive into specifically talking about expressions, working with arrays and objects, aspects of action configuration, and application lifecycle management. So these are kind of the deep topics that we have on Flow. So let's jump right in and talk about the kind of the top 5 best practices that I'd like all of you to be aware of as you're building out solutions using Flow inside of your organization. So the first one is documentation. Now, if you have any background in writing code, you may be familiar with this. Just like writing code, if you write a bunch of flows and you don't document what you're doing, you're going to run into trouble. So it's the same thing. Even though we are no code, low code, documentation is just as important. Doing your filtering in connectors, and I'll talk about why this is important in a moment as well. Making sure your flows are as generic as possible. Don't hard code a bunch of stuff inside your flows. Again, if you have a coding background, this actually makes perfect sense. You shouldn't be having a bunch of constants all over hard-coded in your information that you have in your code. Use solutions. So for those of you who don't know what solutions are, I will talk about this. And finally, make your flows resilient by adding error handling steps. So why don't we dive into these a little bit more. So for documentation, if you don't know, every flow has a description that you can provide. And you may not want to put the description in for yourself, but if you have other people collaborating on a flow project, definitely recommend putting that description right there. Anybody who clicks on that flow can see it. But it's even more than that. Inside of the flow itself, be sure that your actions are named legibly and in a way that describes specifically what that action does. So I'm going to be showing you some flows that we're using inside of Microsoft to manage our release notes process. And you're going to see I have probably 20 or 30 different actions that are all just reading and writing from CDS. If all of those actions were list records 1, list records 2, list records 3, list records 4, that would be, of course, impossible to ever understand what's going on. So it's really important as you build your flows to name your actions appropriately. Now, a small feature we released recently is you can actually rename actions now. So those of you who may have used Flow in the past know if you have a flow action that depends on another flow action, once you do that, you actually can't change the name of the first action because it would require updating that second action. So we've actually fixed that. So now you can rename after you've added. You can change the trigger now as well. So we're trying to make these things easier. There's still a couple bugs here or there with that, and I think if any of you were in the pre-day on Sunday, you encountered, you saw one of those on stage. But yes, you should be able to rename these things now. So don't leave the default names, but if you forget to change it, you can after the fact. And likewise, when you build your flows, add comments into the actions themselves as well. You don't want the name to be some super long paragraph describing what this thing does, but you can add a whole paragraph if you'd like inside of the action, so that way somebody clicking on it can get a sense of what is going on. So the next of the top 5 tips is filtering your data in the service. Don't try to download 100,000 records into a flow and then do all of the filtering on the flow side. Okay? That's going to incur a significant performance penalty on what you're doing inside of your flow. So instead what you should be doing is, I know it's painful, I know it's obtuse, but learn some basic OData syntax. Okay? A lot of services use OData as a standard for how you can filter information. So what you can do is, most services that allow you to list records have that ability to filter a query. Do that as much as you possibly can. Try to push as much filtering and querying up into the connectors And by doing that, the amount of data you have to work with in the flow itself is as small as possible. And that'll make sure your flow runs as quickly and as efficiently as it can. And if you don't do this, you're going to end up hitting pagination limits. Now, another kind of somewhat unknown feature of flow is you actually can enable pagination inside of flow. So if a single request can only get back, say, 250 rows from SharePoint, and you really, really, really need to get back like 1,000 rows from SharePoint, there's actually a setting you can flip, and it'll actually go and suck down every single page of content from SharePoint. But generally, I'd recommend against this, because if you're getting all of that data, that means you probably haven't constructed your filter in a tight enough way to be able to get just the data that you need as you build out your flow. So that's another thing to keep in mind, and this will be very important, especially when you start thinking about throttling. Flow doesn't let you just do an arbitrary number of actions. There are limits to how many actions a flow allows in a single run. It's about 100,000 actions every 5 minutes, which may sound like a lot, but I see people all the time who have flows that download 100,000 records and then expect to be able to execute 10 actions on those 100,000 records. That's 1 million actions. That's not going to get complete in 5 minutes. So be sure that you're filtering as much as you can. The next important point is keep your configuration generic. And what I mean by this is, first of all, don't use user accounts if you can avoid it. Use a service principal if you can. Flow has full support for service principals for any services that support it. And that's an important caveat, because there's a lot of services out there, Microsoft services, that don't support service principals. The most problematic ones you can imagine, Exchange and SharePoint. They have to be a user account in order to use an Exchange mailbox. There is no way to create an application identity that has a mailbox associated with it. But luckily, if you use the Common Data Service, that fully supports application users where you have service principals assigned to permissions inside of the system. So use that if you can. And if you can't use a service principal, then use a service account. That's an account that isn't bound to a particular user. It is you're going to have to burn a license on it. But that's really important, because if you don't do that, if whoever built the flow, leaves the company, all of a sudden that flow is going to stop working. Now, just to remind you, not all is lost if you forget to do this, because all flows are always visible to the administrators of the instance. So they can come in. If somebody does leave a company suddenly, you can reassign that flow to somebody else. You can also have flows that are owned by groups of people or teams of people, so you can have multiple people contribute to that flow. So it's not like once a single person leaves, if you did use a personal account, you're doomed, but you don't want to get in that situation in the first place. And the best way to do that is to use service principals and system accounts. And also, don't hard code things into the flow itself. Don't have your flow full of email addresses that are approvers, or a particular database that you're connecting to. Because if you want to ever be able to create an application lifecycle on top of your flow, you want to be able to test out your flow in one environment and then move that to a production environment. You're not going to be able to do that if you have all of this config hard-coded in your flow. And especially things like send a copy, which is a new feature that's in preview that allows you to distribute a flow to your entire organization, so that way the other people in your organization can take and use that flow. That won't work if you hard code all the config, because every single person that uses that flow, they're not going to be editing that flow. They're just going to be using it. So if you have configured a flow that sends yourself an email when a file is added to OneDrive, and you send that to everybody else in your company, you're going to get an email every time that anybody else uploads a file on their OneDrive. So you don't want that, right? You want to make sure that if you're using a person's email, for example, use the Office 365 Users Connector to get that of the context of the user who's signed in the flow. So that's really important. One of the things that's coming soon is a new concept called environment variables. And this will help you to make your configuration, yes, I heard some applause over there, your configuration even more generic. So today, for example, if you do have a flow, and say that flow is bound to a SharePoint list, it's really hard to have that be a completely generic flow, because that SharePoint list is baked into the flow, right? What environment variables will allow you to do is completely separate out all config from the flow definition itself. So you have a series of variables at the environment level, which means they can be used across multiple flows, that you can then have your flows reference. And those environment variables can, of course, vary from environment to environment, which means you can have a test environment where you have a test SharePoint list, and a test SharePoint site, and a production environment where you have a production SharePoint list and a production SharePoint site, but the flow itself, the flow definition, can be identical in both environments and just references those environment variables. So this isn't available quite yet. It's coming out this summer, but definitely as soon as that's available, strongly recommend using that and leveraging that to make your flows generic. If I have to have just one takeaway from this, it's item number 4 in the middle of the list, of course. Use solutions. Solutions, well, I guess by show of hands, how many people are familiar with what solutions are already? Okay, so about 2/3 of you or so. So for those of you who already know what solutions are, great, kudos. For those of you who don't know what solutions are, that's okay. So solutions are available in any environment that has CDS associated with it. So the first thing is make sure your environment has CDS. And once you have CDS associated with an environment, there's a new tab that will show up in the left nav called Solutions. And Solutions give you a way to group and to bring your flows together, so that way you can actually move your flows along with the associated dependencies between those flows from environment to environment. So that's really important. And once you have environment variables, that will make solutions that much more valuable. And I'll talk a little bit more about that at the end. And then finally, for the last tip before we start diving into expressions, use error handling steps. A flow will end if there is an unhandled error. So if something goes wrong in the middle of your flow and you don't add any error handling steps, that run is going to terminate. Which means if you have other actions down there that you want to execute, they won't run. And also, if your flow is indeed doing something that's business critical, you want to make sure that you get notified that there's some sort of alerting or possibly some sort of rollback or remediation that happens if that flow has had something go wrong with it. So that's where error handling steps come in. And you can use a feature called configure run after. I'll show you how to do this in a moment. That gives you the ability to configure these error handling steps. So that's really important as you build out your flow. If anything is business critical and you don't have an error handling step in there, you're setting yourself up for a world of pain. Okay, so with that, I am going to switch over to my machine. So what I'm actually going to be showing you throughout this session is a real set of flows that we use to manage our release notes publishing process inside of Microsoft. So notice this is in a development environment that you can see here. So I'm not editing anything live in production. Number one thing is use solutions, which means build your stuff in development environments before you bring that to production. There is a separate production environment where the stuff is running for real that we use solutions to move that stuff in. But for this flow, for example, you can see this is a relatively complex flow. And starting from the end, notice we have error handling steps here. And the way that we did this is you can go to this menu right here and select configure run after. And as soon as you do that, you can see I can now have this action that runs if any of the previous actions above this have failed or are skipped. And this is an important detail because if, say, the very first actions in this flow fail, say getting the deployment history of flow fails, all of these actions below it are going to be skipped. They're not going to run because they may need and rely on data above it. So if I come down here and if I only have this error handling step look at the failure of the previous action, if this action is skipped, this will never run. So generally for your error handling steps, you're going to want to look at both skipped as a status as well as failed as a status. So that's error handling, but some of the other things I'm doing in this flow, for example, is when I query the common data service, which is where we store a lot of the information associated with our release notes process, you can see I'm using these OData filters to query information. And this is really important because I could theoretically have filtered all of these rows inside of flow using this filter action here. But I'm not doing that because I actually can push much of this logic up into the server because we could have hundreds or thousands of deployments across all of the services that we have. But what I'm looking for is just a very specific set of deployments inside of the common data service. So I can filter by any number of fields here. So you can use standard OData filtering. In this case, this is an and of just checking that the deployment value is equal to one field and the region value is equal to another field. I can do that in this filter query. Now, there are some things that I have to filter in the flow itself. So there are going to be times where you're going to need to do that, and that's okay. In this case, for example, I need to be able to filter this based on another value that can't be pushed into the OData filter. So that's okay, so you can do that, but you should generally try to push as much information into these filters as possible. So let's see, what other things do I want to note here? Error handling steps, filtering arrays. Oh yes, and then of course, you may notice in this flow as well as in this flow, there's lots of different actions, right? And all of these actions are calling into CDS. But I've named, and we've named, all of these actions, even the conditions and the loops, to make sure that you can look at this and understand what's going on. If you don't do that, if I'm inside here, it can be very easy to get lost when you're trying to fill out these actions, because there's going to be so many different outputs, even for the for each loops. So if you don't name everything inside your flow with a unique name, it's going to be very difficult to work with this content as you get to more advanced flows. So with that, let's actually start talking about data flow and expressions. So hopefully all of you know this already. Inside a flow, the information can be passed from step to step, of course. Something that does throw people off from time to time is they say, hey, I'm missing data in one of my actions. And the reason that would happen is we do intelligently filter the fields that you can use as you build your flow based on data types. So if you have a field, for example, in action 2, that is a number field, you're only going to be able to use automatically the size and the count from the previous actions because those are also number fields. Now, you can explicitly use an expression to cast from one number type or from one data type to another data type. But we don't do that automatically because if we did, something could go wrong. What happens if I try to use a file name and the file name isn't actually number? Well, that will fail. So that's something to keep in mind. And before I dive too much into expressions, I do want to call this out. For those of you who also use Power Apps, you may notice that the expression language that we're looking at today is different from the expression language that Power Apps uses. This is simply a matter of heritage, where these things came from, both inspired by Excel, but that don't use the exact same language. And there are some capabilities you can do in Power Apps you can't do in Flow, and some things you can do in Flow you can't do in Power Apps. So it's just the way things are. Over time, we are looking at how we can smooth these barriers and bring these two languages closer together, so that way you don't have to remember that in Flow it's called substring and in Power Apps is called mid. It's just different artifacts of history. But over time, we do hope to smooth this out. But at the moment, not quite available today. So why would you want to use expressions even at all? Well, even in the previous example that I was showing you, we need the ability to convert data types, of course. It also allows you to do things like simple inline calculations. If I want to be able to just add some numbers together, do arithmetic, generate something like a current time if I need to do some date time math, handling optional values. One of the things that I find really valuable is the ability to do if statements inside of a single action. And I can show you, a really important example of why you can do that in a moment. And of course, working with lists and other advanced data types like objects. So creating an expression is pretty straightforward. You click on Add Dynamic Content inside of the Flow Designer, and then you switch to that expression tab, and then you can just type whatever you'd like inside of the expression. We have IntelliSense baked in, so as you type, you get some recommendations about what's happening, and then you click OK, and it'll go add that action directly into or add the expression directly into the action that you're working with. So for those of you who haven't spent much time with expressions, I'll just spend a minute breaking down the exact details of how to type expressions. So you always start with the outside parentheses and the name of the expression. So what we're going to do in this example is just convert from an object on the left. You can see this item is due at time, and literally that is in the string, is brackets time. And I want to be able to stick the current time into that. So I want to use the replace expression that can replace content inside of a string. So first of all, I need to understand that replace has 3 parameters. And you can find this both in the documentation that we have, and also IntelliSense will help you with this. How many parameters does this expression have, as well as the names of the parameters as you build them out. Next, you can add your specific static strings into the expression. Now in Flow, unlike in Power Apps, if you have a string, so some text that you want to use in your expression, you have to use single quotes to represent that string. You can't use double quotes, and that's just an artifact of the fact that this is serialized into JSON. So if you use double quotes, it would escape itself, and it would be difficult to work with. So I want to literally replace the string time, which means I need single quotes around that. Of course, you can use expressions in other expressions. It would be pretty limiting if you couldn't. So in this case, I'm going to get the record that I have, and in particular, I want a certain property from that record. So you can use this square bracket syntax. You can also use dot syntax, so I could have typed body get record dot my title. That would work as well. And that's the exact same thing as Power Apps, actually. They both work with records the same way like that. Now, finally, there's one thing that's a little unique to Flow, which is this weird little question mark thing going on here. And what that's about is that's about referencing optional parameters. Because if you just look at strict standard JSON for dereferencing properties, if you don't include that, then this would actually fail if my title wasn't defined. Now what will happen is it won't fail. It'll simply return back null, which is a value that you can then use in other expressions that you have. So that's the anatomy of an expression, and I'll show you a bunch of examples of expressions that we're using as we go along. So before we do that, though, I just want to talk a little bit more about data types. So there's a bunch of different types of strings that we have inside of Flow. These are text types. The most basic is just a regular string. But there's a bunch of different ways that strings can be encoded in Flow. So the most common example of this is if I get an email attachment, I need to be able to use the contents of that email attachment, but it's a file, right? I can't just open it up and look at it. So that's encoded as base64. Also, working with files in general, downloading from OneDrive, uploading to OneDrive, all of that is actually stored as binary. So there's different ways that we can code this. And if you are working with expressions for these things, you will need to explicitly convert from base64 or to base64 when you're working with these types. Now, in addition to strings, there's also a bunch of non-textual representations of data, things like numbers or booleans, arrays, and objects. And some of them are converted automatically, some of them are not. I do not need you or want you to even memorize this slide. But the idea here, and you'll be able to look at the slides after the session, is that some data types are automatically converted when you work inside of Flow. Some are not. And you can tell based on kind of the coloring here and the yes and no's where data is automatically converted. So we can automatically convert between, say, an integer and a floating point number. All integers are valid floating point numbers. But the inverse isn't necessarily true. If I have a floating point number, that isn't necessarily an integer, so we can't automatically convert that. And then the data types, we will automatically try to convert those. Those are the green boxes as much as we can. But there are also expressions for you to use there if you want to explicitly convert information yourself. So we've also released a new condition builder. And with the new condition builder, it allows you to construct advanced queries just using the simple point and click. But some people have asked, wait, what happened to that advanced condition builder thing that I could do before, where I could just put whatever expression I want? Well, you can still do that, and the pattern there is by putting an expression on one side of the condition and just saying equals true to get that same behavior that you had before. And I'll show you an example of where we do that inside of Flow. So this if expression, this one is really valuable. It helps you to avoid things like what you're seeing on the screen there, where you have all these nested conditions and types of things to be able to have just a few pieces of different logic run based on what's going on. So I definitely recommend using that if it can reduce or consolidate the number of actions that you have inside of your flow. Now, with optional values, I mentioned this a little while ago. When you get a null value inside a flow, you have to do something with it. You can't just pass it around and expect it to work on every other action. So what you can do is use something called the coalesce function that allows you to provide a default value if you do get something that is null. So the example here is if I have a record that I'm getting from the Common Data Service and one of the columns isn't defined. There's no value there. but then I need to pass that to another action. In order to do that, I need to coalesce and provide this default value that you can then use in the flow itself. Okay, so we can switch back and take a look at some examples of these. So inside this flow, what's actually happening is we store a bunch of our release information in Azure DevOps. So that's where a bunch of it is. And what we do then is we take that release information and we put it in the common data service so that way the PMs on the team and the doc writers can work on those release notes for that particular release. So what this flow is doing is it's going to Azure DevOps and it's running a query that has all of these release records, and then it needs to put it into the common data service in a certain format. So I need to iterate over all of these things, so that's why I have a for each up here. And what I'm doing is I'm only adding certain releases into that common data service, because sometimes a release, for example, is canceled. So if one of the releases is canceled, I don't want to go and update that inside of our common data service database. But here you can see you can still use expressions inside of this new condition builder. So in this case here, I have what may have been an advanced expression before. And you can just put whatever you would want into this advanced expression. And then on the right-hand side, you can do things like are equal to null or equal to a certain value. And if you want the expression on the right to be equal to just true, you can come here and just type true. And this will put the actual value into that right-hand side. So this is how you can deal with really, if you want to use whatever advanced expression you want over here, and just say that that is equal to true, but still leverage all these other nice condition builder things. Now inside this, if I wanted, I can also group these conditions together. If I wanted some more complex logic around, if either of these are true, I could say or for this, and for visually to simplify this, you can collapse that. So the new condition builder is a really great way to build pretty advanced conditions inside of your flow as much as you need. But I mentioned there's also this if expression that's really useful. So we have a status field associated with each of those deployments in the common data service, and that status field is an option set, so it's a drop-down, right? And option sets inside of the common data service, they're actually stored as numbers. And that's just the way it's stored internally. So I need to be able to map from the status field, which is a string inside of Azure DevOps, to the status field, which is a number inside of the common data service. So I can do that using this if expression. So we can just take a look at this, and why don't I do something I commonly do, which is I'll just copy this and put this into Visual Studio, or not Visual Studio, but Visual Studio Code. And I'm going to zoom in a little bit so you can see this. And what this if expression does is it allows me to compare, for example, if the status is equal to complete, I want to use this number. Otherwise, if the status is in progress or on hold, I want to use this number. Finally, if neither of those are true, I'm going to use that number. Now, I could have used conditions like this one to do that, but I would have had to have in each one of those branches a separate copy of the action that goes and updates the common data service. And that would have been really annoying because I would have then had to duplicate all of this other config that I have associated with this flow. So I didn't want to do that, but by using this if expression inside of this single field, I was able to very easily just have this single expression and fill out that particular value, and I don't have to duplicate any of the additional actions or anything else inside of the flow. So some of the other things that I can show is working with the compose action. So the compose action is very useful because it allows you to just store a value that you can then reference in other places in the flow. Now you may think that sounds a lot like a variable, but there is an important difference between compose and variables, and that's that a variable, once you create it, can actually be changed and updated. Whereas compose, that's static. You use that once, or you define it once, and then you can use it as many times as you want. And that implies there's actually performance improvements by using compose. So I want to be able to use this string a few different times throughout my flow. So I can do that, and then I can use that deployment ID as I go and have my other actions that go and update various aspects of these records in the common data service. OK, so I can switch back to the slides here. OK, so now let's start talking about arrays and objects. So there are these two complex data types inside of Flow. So most data types that you work with are going to be simple. They're going to be strings or numbers. But working with complex data types is actually really important. And you're going to be, if you're building advanced flows, you're going to actually be doing this a lot as you go and build out your processes. So as an array is just a list of things. We actually use different terminology between Power Apps and Flow. So an array in Power Apps is called a table. Really, they mean the same things. An array is the same thing as a table. It's just different terminology. So if you ever see tables in the context of Power Apps, just think about arrays as we call them in Flow. And likewise, in Power Apps, objects are called records. So a record is what you can see on the right here, and that's just a series of properties that may point to primitives or even other complex types. You can have records inside of records inside of records, or tables inside of records, or in the JSON terminology, objects inside of arrays, etc. So these can be really as complex as you need to define your data structures inside of your flow. Now, when you're working with arrays, there are a few different ways that you may want to integrate with that. One is by having a for each, like I just showed you, inside of your flow that takes a list of items, and for every single item in that list does some amount of work, maybe querying, updating, reading data. You may just want to get a particular item from a list, or maybe you want to be able to filter a list down, or work with the different types of action. So basically, no matter what the contents of the array are, these same types of operations are going to be useful. So starting with apply to each, the first introduction you may have to this is you're just building out your flow for the first time, and then you add something in, and bam, you get this apply to each surrounding your action. It can be a bit surprising, but that only happens when it needs to. So that happens whenever the thing that you clicked on is inside of an array or a list of items that come from a previous step. So that's why that's happening automatically. Now, if you want to avoid that happening automatically, you'll need to use an expression to get a certain item from that list. So that certain item that you can get a number of different ways. You can get the first item from a list, or the last item, or even a specific ID of an item. If you just want to get the second item, you can do that by typing square bracket 1, close square bracket. And yes, I did say 1 because arrays in JSON start at 0, not 1. So that's something to keep in mind. Again, this is low code, not no code. So there is a little bit of coding tricks you're going to have to remember. But yes, the first element of an array is 0, not 1, as you can see in the example on the screen here as well. So in general, when you go and you use arrays, just be sure that you're keeping that in mind. And you can also use the expressions to just grab the first one without using those square brackets. So another thing that you may want to do with an array is convert it to a string. And this means joining together possibly a list of things. Now, if I have a list of email addresses, say, all the people who report to a certain manager, I want to send an approval to them. You can just use the built-in join action that we have. We also have a join expression that you can use to combine all of those email addresses into a single string that you could then use to send an email or to send an approval task. Something to keep in mind with the join action is you have to have a list of strings, not a list of objects. If you have a list of objects and you want a particular property from those objects to be put into a string, you'll need to use another action called select that I'll talk about in a minute. You can also, if you do have a list of objects, you can create an HTML table from that with a nice column for each of the properties in that record. And this is particularly useful for sending out emails. If you want an email summary to be sent out, you can take that object inside that array and put it into an email very easily. Now, filtering, I already talked about this a little bit, but filtering, again, try to have the connector do it for you if you can. Otherwise, you can use a built-in action called filter that allows you to filter down arrays based on the properties inside of that array. So transforming arrays. So this is where that select action that I mentioned comes in. So what select does is it takes an array of objects that are in a certain format and can transform each of the items in that array that you can then use in another action. So for example, let's say I have a list of objects that have properties like display name and mail. So those are the two properties that I get. But I need to be able to get just the email address from that so I can join it together in a string. I can use a select action and click specifically on this T icon that indicates that I'm going to put in a specific, just a simple type of data. And then I'm going to select the mail property. So what this does is this will return, it will take a list of objects and return a list of strings. Now, there may be other cases where you actually want to pass an array of items to another action, but the names of the properties in that other action are different than in the source action. You can also do that transformation inside of Flow using the select option and then use that other icon to fill out the name and email, for example, of that. So when you're passing data into an array, if I'm sending an email with attachments, I can just fill in a particular name. I can say, I want attachment 1, and I'm going to pass in some content. But if I do want to pass in a full list, a dynamic list of attachments, I can do that. But I do need to transform the array from the initial format that it came from, wherever it came from, into the destination format that's inside that array. Okay, so some other things you can do with lists is you can check containment using the contains function. You can also use the union function to combine arrays together. And this can help you weed out, for example, duplicate items inside of an array. So I talked about arrays a lot, but objects are also really important to work with. And objects are useful because they allow you to create a dictionary of data that you can then use to reference information. I'll show you an example in one of the flows that I have where we do that. And what's nice about objects is not only can you can type the JSON representation of that object in, but we have built-in formulas for setting and adding and removing properties on objects as well. So this is particularly useful if I have a variable that contains an object and I want to add a series of properties in a loop to that variable. You can do that by using the add property expression in each iteration of that loop. So you can build up an object or a dictionary of things that you want to map. And finally, as you're building out expressions, keep in mind escaping rules. So these are important because if you have, for example, a single quote inside of an expression and you type that, that's going to end whatever string you have. So if I, for example, in here, if I had it's a great day and I had a single quote here, that would fail. I need to type the single quote twice, which of course is very different from a double quote, inside of the string here, and that's how I can get it working. Whenever you're working with expressions, the spaces inside of actions are converted to underscores, so keep that in mind. And if you have an @ sign at the beginning of an object property, you'll have to type the @ sign twice, or else, again, it'll think that it's an expression that you're working with. Okay, so let's take a look at some more examples here. So in this flow that we have, what I've done at the top of the flow is I've done a pattern that we use a lot where I create a map from one string to another string. And this is important because in our deployment history, we have these nice friendly strings. I can make this a little bigger. For each of the regions that we deploy something to as a part of our deployment cycle. But in the Common Data Service, there's a bunch of GUIDs and IDs that represent these things. So rather than having a big if-else or a switch condition with this, I can create a map, which is an object that allows me later on, I can just, as I reference this, when I get deployment, I don't remember exactly which one of these expressions I did it in. Yeah, it's this one right here. So you can see this takes that ID, or it takes the friendly name, and because I'm using this inside of square brackets, it allows me to get back that unique GUID that represented the ID of that record in the Common Data Service. So you can see here, this gets me the friendly name, which is the key in this object up here. So this would return back East US. And the map returns back that unique identifier. So this is how you can have data just kind of persisted in your flow that you use to map from one set of information to another set of information. And of course, when I'm working with this flow, there's different places where I'm going to be getting the first item from an array, or maybe the last item from an array. And this is useful because I may want to, let me see what I do with that. If I have a list of things and I just want to get a certain one, I can do that. So in this case, maybe I know that I'm only interested in a particular item. Down here, I could just type first in the expression, or I could type a specific ID. So I have an example of that here where I'm actually taking a string and I'm splitting it up to get different parts of that string. And I want to get the third segment from that string. You can see here, so in this case, the title of the string is a string with spaces in between each of the words. And I want to get the third word. Well, how do I do that? The way that I do that is I split it on a space, and then I do bracket 2, and that will give me the third word in that string. So you can do this for all types of string manipulation and other things inside of your flows. Okay. So let's talk a little bit about action settings and configuration. So I definitely recommend checking out the settings that are associated with each actions, and I'll talk through what each of those are and where that's useful. But this allows you to configure things like pagination and timeouts, retry policies, and whether or not actions execute sequentially. So that's always a place to check out. And as you're building your flows, you can use parallel actions to have different actions run at the same time. So this is useful inside of a error handling scenario where you want one type of error to happen while the rest of the flow can continue executing. You can also have loops that run in parallel. So this is a setting, if you go to the action settings that I was just mentioning, inside of the flow for that for each, you can actually enable concurrency, and that you can have a single loop that runs 50 items at a time. So that can go much more faster. It can really accelerate the performance of your flow. Now, with looping, you can use do-until loops to repeat until some condition is met. So if you have an approval process, for example, where you have a multi-stage approval, and if a stage fails, you want to ask somebody to go back and review it and then resubmit their approval. You can do that by using do-until loops. So you can do that here. This is what it looks like when it's actually inside of a flow. Variables are also useful for accumulating information as you go along. You have counters and the ability to append, checking if something is happening. But don't use this to just store a static string. I do see a lot of flows where people, what they'll do is they'll have at the top of their flow a bunch of initialize variables for strings, and then they just never use them throughout the flow to change them or to update them or append to them. You don't need to do that. You can just compose once at the top of the flow, and then you don't need to use variables for that. Another pattern that's really useful is this idea of using terminate inside of a flow. So if you want to be able to escape from a particular branch of logic, you can add this terminate action, and it will end the flow execution automatically as soon as your logic has been met. And finally, asynchronous actions give you the ability to have a flow in the middle with an action in the middle that actually waits on some event. So you can actually use triggers in the middle of your flow. It seems kind of counterintuitive. A trigger is a thing that starts the flow, right? Well, technically a trigger is just something that has an event that happens, which means you can have an event that happens in the middle of a flow. So in this very simple example I have on the slide, what I actually want to do is every time I send a high importance email, I want to wait until somebody responds on that thread. And if nobody responds, it's going to send me a notification to remind me to ping the thread. So this actually uses a trigger as its second step, which is, like I said, a bit counterintuitive, but you can actually do that right inside of a flow. OK, so let's switch back. So inside of flows, there's a bunch of different patterns that you can use for having things like loops. This particular flow has pretty much everything that you can imagine in terms of looping, conditions. But one of the other patterns that's really important that I want to mention is encapsulating your logic into separate flows. So if you have a particularly advanced solution where you have a bunch of different logic that you want to run from different places inside a flow, then what I'd actually recommend is having flows call other flows. So you can do that by using the fact that each flow can have an endpoint that you can invoke. So for this particular solution, what we've done is we've actually built 8 different flows that are called from a single master flow. And inside each of these flows, they may not actually be too complicated because this is intended to be some amount of encapsulated logic that we have that you can look at. So we can take a look at what these flows look like. And these nested flows, generally, they're all going to have a common pattern of a trigger when an HTTP endpoint is called, and then a response back to that endpoint with some information. So you can see this flow is an example of that parallel execution I was talking about. I need to go retrieve some information, but I don't need this to depend on that or that to depend on that. So if that query takes a second or two, it's actually faster to run these 3 in parallel than it would be to run it sequentially. And normally, a second or two wouldn't matter. But if this flow is in a nested flow that's being called 1,000 times by another flow, every second matters. So that type of optimization is useful. And you can see again here, we have these error handling steps that can respond back to the flow calling this with a particular failure. But this is what all of these nested workflows look like. And then I have a single flow that's the parent flow that actually calls all of these children flow. And we can zoom out a bit on this one just to get a sense of how this one works. But this flow, what it does is it goes and retrieves a bunch of data, and then every one of these green boxes is another flow that's being called. And you can tell that this flow is actually running inside of, in fact, 2 nested loops. Because what it's doing is it's getting, in this case, all of the different products that we have inside of the business applications. And for each of those products, it's going and generating the release notes document for them. And this works because we have all this data stored in the common data service. We list it, and then we iterate over each of those products. And for each product, we're generating a different type of document. We're generating the release notes table of contents. We're generating the release notes page for each release note. But I don't want to have all of these flows, the content in these flows, pasted into this flow, because although this looks pretty big, imagine what would happen if that flow it would become completely unmaintainable. It would become completely unmaintainable. It would become completely unmaintainable. So that's why having flows call other flows is something that's particularly useful that I recommend doing. So the other thing I wanted to show is the action settings, so we can take a look at those inside of this flow as well. So for something like a for each, as I mentioned, you can configure how much this runs in parallel. And you can see because this flow is iterating so much, I have turned concurrency all the way up to the max. I want this to run 50 records at a time, so that way it can go kind of as quickly as possible. But for actions that actually call out into other connectors, there's a different set of settings that we can look at. So one is you can see whether or not it handles asynchronous pattern. And this is useful for things like approvals. You can configure the timeout for an action. How long will this run until it's canceled? As well as retry policies. So you can actually put custom retry policies here. If I want an exponential interval retry policy, which will actually back off as things continue. Or I just want a fixed interval retry policy that just executes a certain number of times. You can see you can have this retry 90 times if you want. Generally, I wouldn't recommend that, but you can absolutely do that if you need. And for actions that list things, there's another setting specifically for pagination that you can enable here, you can turn on pagination, and you can still define a threshold of items to work with. But this allows you, if you have a service that returns back a small number of actions or records at a time, to be able to work with that. So that's all of the various settings that you can work with. And we're going to wrap up by talking a little bit more about application lifecycle management. So I already spent some time talking about this, but really at its core, the goal with application lifecycle is to make sure that you're testing your things out before you're deploying them to production, and then continuing to iterate. And the way you can do this is by creating a separate development environment from a production environment. So in your development environment, that's where everybody is building their flows, testing things out. And after you've validated that, take that inside a solution and move that to production. And you shouldn't be making any changes there. But what you may want to do is actually take the data from production and save a copy of that in development, so that way you have real sample data that you can work on. So environments you can configure in the admin center. So if you go to the platform admin center, you can set up your environments there, and you switch them from that control at the top right of your screen, where you select what environment you are currently working on. Then the solutions themselves, these are how you get content from environment to environment. If you have any experience with Azure, a solution is somewhat similar to a deployment or a resource group inside of Azure. And you can access these from that left navigation inside of Flow. And that example I showed you where there's all those nested flows, that was a solution. It's a single solution that contains all of these things together that I can move from environment to environment. And that's really important because I probably, across all the solutions, I probably have hundreds upon hundreds of flows myself, which would be impossible to manage in the My Flows list, because that's just a flat list of the flows for yourself. If you're building something as a part of a production deployment, you should use solutions, and then it doesn't show up in your My Flows list that you have to be working with all the time. So with that, I think we have some time left for Q&A. But before we do that, definitely recommend joining the Flow community. There's a bunch of people there that are happy to participate in conversations about expressions and advanced things like that. And as well, check out user groups. So we have lots of user groups kind of around the world now, dozens of these, and it's a great place to have conversations about the advanced capabilities of Flow and the beginning capabilities of Flow. So I definitely recommend checking that out. So with that, we have about 10 minutes for questions. So just come up to the mic if you'd like, and we can discuss. I think you have to turn on the mic. Yeah.
There we go.
All right.
I heard you mention in an earlier session that you're going to have some improvements to the expression editor. Can you kind of talk about that?
Yeah, absolutely. So you may have noticed a couple times I would actually take that expression and copy it into VS Code to work with it. I did that because that expression editor today is kind of small and fixed width and difficult to work with. So what we're going to be doing is we're going to be enabling you to expand that out and take up as much space as you want. So you'll still get IntelliSense like you do today, but it'll be, you can expand that to be, full width of the screen if you'd like, and work with your expressions. Personally, what I will do actually a lot is I will even, if you put line breaks inside expressions, if you have kind of complex nested expressions, I do that as well. And of course, in a single line text box, it's hard to see and work with. So that'll be something that we'll be releasing soon.
Will it still stay bound to the action, or will it, that's another problem as you scroll?
Yeah. So we're looking at design similar to the way that Power Apps works, where there's a fixed bar at the top of the screen that you can work with. So we'll probably support both modes, where I can just do it quickly in line, or you can expand it, and then it can be fixed and kind of as big as you need. So we'll support both approaches.
So what kind of techniques do you use if you have a complex flow with a lot of connectors that need to be signed in, and then you need to export that, like, say, to another tenant or something, and then you have to go through each one of those connections and re-sign each one in?
Yep. So this is something that although not immediately intuitive, will actually be helped with environment variables. Because what's going to happen is you can actually have a connection that is an environment variable. So you'll be able to set up the connection once in the destination environment. So for, if you do have a flow that uses 10 different services, you're going to have to set something up 10 times. Right? So you're going to set that up 10 times, but then on subsequent imports, or if you have multiple flows using those connections, you can have that reference that environment variable that points at that connection. So you won't have to reset it up, or also you won't have to like hunt and peck inside of the flow to find the place that that thing needs to be authorized. You'll do that all up front at initial import time, and then subsequent uses and imports of that flow will be able to use that connection. Yeah, it's definitely something we need to work on.
Is there an expression for conditions for case sensitivity on, say, if I get an attachment or something and I want to know if it's a PDF or not, and I've put in before that it's a lowercase PDF,
Yep.
and it failed because it's a capital.
Yep.
Is there a case sensitive thing where I can put that in there?
So that's a great question. We don't have a case insensitive compare function, but we do have a way to solve this. And this is a common programming paradigm, which, if you're come from a programming background, you may be familiar with. But what we can actually do is on both sides of the comparison, convert them both to lowercase. And what that does is, if you have any variation, since they're both being converted to lowercase, they will be the same after they've been converted to lowercase. So that's something that we do. And I think it's supposed to be to lower because there's some languages where it's actually not, like in Turkish, if you have, there's a letter that has two variants in uppercase and one variant in lowercase. So you need to go to lower to get that single variant, or else your comparison might fail.
Yeah, so what about scope variables instead of global? When is that going to roll out?
So we don't have any imminent plans for variables inside of a scope. So for those of you who don't know, today when you initialize variables, you initialize it once at the top of the flow. You can't initialize inside of scopes. So that's something that we're looking at doing, but we don't have a specific timeline for it today.
Perfect, thanks.
Yep.
You talked about the OData filter query section, and
Yep.
the ones I'm doing, a lot of times I'm seeing that you can't do multiples. Yours, I saw you had a multiple, so I don't know if it's a new version or if I'm doing a different data type.
So by multiples, you mean like something and something?
Right.
So ultimately, what queries a given service supports is actually based on that service. So like if you're working with, say, SharePoint, it might support a different number of different queries than, say, the Common Data Service. So like the examples I was showing using Common Data Service, and that supports some pretty complex OData things. You can even look at like child properties of an object or relationships between objects. I don't know, is that SharePoint that you're using or the Common Data Service?
The one I think of is Excel. Off the top of my
Excel.
head.
Yeah, so the Excel service, it's entirely possible, just doesn't support joining multiple filters together. So the best thing I'd recommend in that case is you do one filter on the service, and then you have to do the second one inside of the flow itself. And just pick whichever one will get you the smallest number of rows to do in the Excel connector first.
Thank you.
But yeah, there are variations across different types of connectors and services.
Hey, great talk. I noticed you pasted your expression into VS Code.
Yep.
I do the same thing, and it's really helpful for long, complicated expressions. But as far as I know, there's no extension for VS Code that can actually read workflow definition language. Do you know of one being developed?
I don't know of one being developed. I think it's a great idea, but it's not something that I think we're working on at the moment. If anybody in the community wants to contribute one, that would be awesome. Otherwise,
Yeah, that would be really helpful.
Yeah. But it's a great idea. Yeah, I think we have time for one more question, and then we have to wrap up.
So when the environment variable comes to flow, is it common across like Power App and everything, so that when I export into a solution, I can use across everything?
Absolutely. So that's why it's called an environment variable, because it actually works for everything inside the environment. Okay. So if you have a Power App that connects to a SharePoint site and a flow that connects to a SharePoint site, you can have a single variable that has that config. You reference from both locations. Even from like plugins inside of the Common Data Service, those can even use the environment variables.
Can we use that with custom connectors or just with the?
So Custom connectors don't really have a way to reference an environment variable
Okay.
at the moment, but we can definitely look at that as we go along.
Thank you.
Cool. So that's coming out this summer. The environment variables will be this summer. So thanks so much for joining. Be sure to evaluate if you haven't yet. Yeah, with that, go enjoy the keynote, and hopefully you found this useful. Thanks a lot.